And that's the 600 million, more than million, right?
Yes, that's in 1,000 million.
Thousands, yeah.
So that would be
600
billion.
600 million, right? Annual heat loss million BTU per year. This should be 10 to the power of 6, not 12.
No, 600, yeah.
Right? 600 million BTU.
Right.
Yeah, here is 6, not 12. And that's why here is 6. So I think is a typo here. So 600 million BTU per year I'm using air because of these 6 open doors that I have, and each of them are 10 by 10. Okay? So if I put it into my equation that I have here, which is justified for the number of the days that this door is open and what's the temperature difference between outside and inside, it gives me basically 941 million BTU per year. Per door, I'm losing energy. I have 3 doors. I have a boiler efficiency of 0.65. That means for every BTU, I gotta put 1 over 0.65 BTU in my boiler, right? Because where this energy is coming from? I have a boiler. The boiler is boiling the water is circulating inside the warehouse, right? So the total energy that is going to cost me is going to be $15,000, $15,635. This is the total energy cost because of just 3 doors. Now if I buy wire, $2,000 for each, 3 of them is going to cost me $6,000. In 6 months it pays for it. Right? This is energy, right? That's simple. Before you sit, you look at this, you make a decision based on your judgment, but when it comes to energy auditing, you make your decision based on numbers, right? This is a clear-cut example of how energy auditing is done. Simple recalculation based on the facts and based on the measurement you did on your opening, basically. Now, there are many different types of a table depending on what kind of a door you're using, what is the material, is it metal, is it wood, what's the clearances, what type of wood strip you are using or metal strip you're using. You are using a storm door on top of that, because some doors they have a storm door that they protect basically the wind. It comes up with all kind of a coefficient for how much CFM of the air is being infiltrated basically. If you go search online, many tables come with different kind of a configuration. But what those tables are going to give you, all of those tables are going to give you this CFM, which is the amount of the air that is being used or lost through the infiltration. The temperature difference is something that you always know. You multiply by that, it gives you the BTU hours. You multiply that by the total number of the hours of the year. When that infiltration is happening, you can calculate the total amount of the energy. There are many different charts depending on, for example, the window sizes, how they are changing, what type of a window you're using, is it a metal, wood, poor wood. It gives you all kind of a configuration changes on your CFM usage. Okay. And the technology is helping a lot. The newer window that you get, the newer doors that you get, they're all reducing infiltration. One of the good way of reducing infiltration is using revolving doors. You saw revolving doors in shopping malls or in big office buildings. Why they use revolving doors? To decrease the infiltration. Next time you're going to Macy's or JCPenney places, go from the outside door, don't go from inside door. If you go from the outside door, you realize that one door opens, you enter a space, door closes, the next door opens. Right? The whole point is to increase the infiltration. Because this way, the air that is coming from outside is going to be captured in this small area. It's immediately get hot because there are many units that is blowing air at that small unit. Right? And then when the next door opens, the cold air from outside or the hot air from outside is not going directly inside the building. Right? It's already conditioned. So there are many different ways in order to keep the infiltration or control the infiltration. Of course, this way of having two doors and having a heavy duct air controlling the air is very energy consumption. It has a lot of energy consumption in it and you have to pay for it, but it keeps the temperature control. Another method of losing energy is through conduction, right? Even if this room did not have any window, did not have any door, did not have any of those infiltration in it, and it was a complete wall, what would have happened is when you have a temperature difference between inside and outside, heat is going to transfer through the wall. The way heat transfers is depending on the temperature difference. It depends on the conductivity of the material that you have, thermal conductivity of the material. For example, just to give you a sense of thermal conductivity, metal is a very high thermal conductive material, right? Next time you're making a coffee for yourself, put a spoon in the coffee and put one of those wooden sticks in the coffee. And after 5 minutes, touch the other end, right? The metal is hot, the wood is not hot. Different conductivity. One of the reasons you see this type of a material are being used in construction is because they have very low thermal conductivity. Brick has a very low thermal conductivity. They put insulation material around it, and the whole point is to decrease the amount of the heat exchange between inside and outside. Doesn't matter winter or summer. Every time you have to basically condition your air. There are also possibilities to lose energy due to radiation, and specifically if temperature is high. If you're working, for example, with factories or plants that they are dealing with melting metals, it's becoming a very important factor in energy calculation. Roofs, when it comes to energy calculation, are completely a different topic. And the reason is because when you are dealing with roofs are exposed purely to sunlight. And depending on where you are in the air, in the latitude, you are going to have different radiation coming from sunlight. And the radiation is energy that is coming to the roof, and that energy is going to make it hot, right? So that energy is going to transfer to the house. That's one of the reasons, if you look at most of the buildings, what they have basically between roof and the ceiling of the first floor under the roof, there is always a space, right? That space is going to act like an insulator, basically. In your houses, that is called attic, right? In summertime, if you go to the attic, it's so hot, right? So that attic is going to supposed to act like an insulator, but some of the energy still gets to the house, and you are responsible for cooling it or warming it. And in order to find out how much of the energy is coming to the roof, there are tables like that. You have to decide where you are. You have to decide what kind of a heat transfer coefficient you have, which I'm going to talk about it. And based on that, based on per square feet, is going to give you how many BTU per hour energy you are going to get. And now, depending on how many square feet you are, you multiply that and it gives you a total energy. Of course, since the energy coming as a radiation, it is important for your roof to see what kind of color the roof has. If it's a white color, it's a dark color. If it's a dark color, it's going to absorb a lot of energy, right? That's why in summertime, you don't wear dark colors like black colors, right? In summertime, you try to wear white colors, because they repel the energy, radiation energy. So, depending on the color of the roof, that becomes also important.
Go to Lawrence Berkeley Lab website and look under the cooled roof. It's a new concept. It's been taking a lot of was basically a lot of people trying to make the cool roof